Alright, this lesson is about inverse functions. So essentially, every mathematical operation has its opposite. The opposite of adding is subtracting, the opposite of multiplication is division, the opposite of squaring something is square rooting something. So inverse functions, functions are just a string of operations. So there are such things as inverse functions where essentially that function undoes whatever the original function did. It's exactly its opposite. So just as a sort of demonstration to help us figure out, have an idea of what happens with inverse functions, I have this sort of silly example of sort of the things that I do when I'm leaving the house, right? So I say goodbye to my dog, and then I turn off all the lights, and then I take my keys off the hook, and then I lock the door, and I leave. So coming home is very much the inverse operation of leaving. So when I'm coming home, I have to first unlock the door, and come inside, right? And then after that, I put my keys on the hook, hang up the keys, and then I turn on the lights. And then I say hello to my dog. I love my dog. So what I want you to notice here is that coming home being the inverse operation of leaving my house, I am not only just inverting the order, right, like the last one became the first one, I'm also inverting each thing. So I'm not just, coming home isn't locking the door and leaving first, right? I'm doing the opposite of locking the door and leaving. I'm unlocking the door and coming in. So I'm inverting both the order and the operation. So the last one becomes the first one, and the first becomes the last, right? So each of these things have been inverted and also in opposite order. So that's what we have down here. We not only have to invert each operation, but we also invert the order. So here's more of a function example. In this function, I've sort of listed what this function does in words down here. So the first thing you would do, if you were plugging something in for x, you would square that x. And then you would add 5, and then you would divide whatever you got there by 7. So doing the same thing that we were doing before, I'm going to invert the order and invert the operation. So instead of dividing by 7 first, I'm going to multiply. It's the wrong color, hang on. Multiply by 7. Then the next we have add 5, so I'm going to both invert the order and the operation. And inverse of adding 5 is subtracting 5. Subtract 5. And then last, I'm going to do the opposite of squaring x, which is square rooting x. So now we have the task of making this, what we just wrote here, a function. So I'm going to start with x because that's like my input, and if the first thing I'm doing is multiplying by 7, I'm just going to have that times 7. And then after that I have to subtract 5, so I have a minus 5 there. And then last I have to square root all of that. So I'm going to square root whatever I got after I multiplied by 7 and subtracted by 5. So this is the inverse. for it. Okay, sorry about that. I never know when it's actually going to go off because it's Friday, so none of the classes are happening. Anyway, so inverse functions, what I want you to sort of internalize here throughout this lesson is that there's a really big trend with inverse functions of switching the input and the output, switching x and y. And you will see that beginning like in this little exercise that we're going to do. So inverse functions undo what the original did. This means that their graphs and tables are related in a very special way. So I first just want to, and I encourage you to pause me right now and fill out these tables for this function. But I'm going to fill it out super quick because I have already done it. There's that. And then, okay, wait. There you go. So this function and this function and this function happen to be inverses. And what I want you to do is try plugging in what we got output on this one. Try plugging those numbers into this function and see what you get. Hopefully you have paused me and realized that this is the result of plugging those numbers in. So what do you notice here? Notice that this is exactly the inverse of the first table that we did. The inputs became the outputs and the outputs became the inputs. We switched x and y. Because this function undoes what this function does. So it's like we did this and then we undid it over here. So we end up with the same thing back that we started with. And their graphs look like this, where they have, they mirror each other sort of along this x equals y line. They're like opposites, exactly. So we're switching x and y on the graph as well. So let's learn how to sort of algebraically make inverse or find inverse functions. We're starting with the function y equals 10x plus 3 divided by 4. So the first step to algebraically do this, and I know that we could do what we did back here, it's just a little bit, the algebraic way is going to end up more streamlined and with less room for error. So the first thing that we're going to do here is switch x and y. Some functions will have f of x instead of y, and you can just replace those with y. F of x is sort of acting as the same thing as y. So, yeah. We do this because x represents our input and y represents our output. So we're, again, switching x and y. So we literally just write the same function again, but with y where x was, and x where y was. Here's my x. All I did was I switched x and y, switched their places. And then we have the next step says solve the equation for y so that we have a function of x that's equal to y. So all we have to do is solve this for y. We're essentially moving all of these operations over. And that's going to look like I'm going to multiply by 4 on both sides. And then I have 4x equals 10y plus 3, because those things cancel. And then we're going to subtract 3 so that that goes away, because I'm trying to get the y all by itself. So then I have 4x minus 3 on that side and 10y over here. So last we are going to divide by 10 on both sides. And finally our answer is 4x minus 3 over 10 equals y. And this is the inverse function to the function we started with. It does exactly the opposite things in the opposite order. So it undoes what the original function did. So that's truly all it is. You switch x and y and then solve for y. And you sort of, it's very much like turning the function inside out. I don't know why that metaphor works in my head. But you're turning it inside out. So the order is switched exactly, and so are all the operations. Good stuff. Anyway, so now we have function notation. it's like very many other things in math. It's a lot easier to know what notations to use to talk about inverse functions. So we actually talked about this on lesson 1 of this unit. How this is just saying this is a function. A function of x. This is blurred out because it's not important. We're just talking about this notation over here. The inverse function, so if you want to say this is the inverse of function f, so the inverse of this function, I'm going to just use this symbol for inversing that function. We write it like f negative 1, f to the negative 1 of x. That looks very much like an exponent because it's sort of, I mean it is really, but it's not acting like an exponent. This is not an exponent. All it means is the inverse, how do you spell? Exponent. This is just saying that this is the opposite function of f of x. So if MathSpace gives you f of x and then asks for f inverse f to the negative 1 of x, all it wants is for you to find the inverse of f. Yeah. We use negatives a lot in math to symbolize inverses. So just don't think of this as an exponent because that's not the way that it's acting. It's not acting like an exponent, it's just notation. Just the way that we write something. So we have been tasked with finding the inverse of all of these functions. I might not do all of them, we shall see. But we're following the steps from the top of this page. We switch x and y, so I'm going to put x out here and y in there. And then we solve for y. So I'm going to add 1. We have x plus 1 equals 3y. And then last, divide by 3. So our inverse function, and forgive me for writing this in the switched the other direction. It just feels weird to write equals y on the other side. It means the same thing though. So this is our inverse function, f inverse of x, but I guess we didn't call this f of x, so we can't really say that. That's our inverse. This one is written as f of x, and what I'm going to do is I'm just going to replace f of x with y just so my life is easier. Like, literally that's all. I don't want to write f of x instead of y this whole time. Come on, x plus 14 squared over 3. So I'm going to replace x with y and y with x, so I'm switching where they are. Because switching input and output, remember that that's a big trend that happens. And then solve for y, so I multiply by 3 on both sides. I have 3x equals, and then y plus 14 squared, those things canceled. To undo squared, we have to square root. So we square root both sides and get the square root of 3x equals y plus 14. And then we take 14 away. So our f inverse of x, written like this, because this is our original function, and that's f of x, its inverse, is the square root of 3x minus 14. Again, sorry for writing that the opposite way. It just feels like brushing your teeth with the wrong hand or something. I don't know. Writing it the other way. So clearly it's the same both ways, but this just feels better. F inverse of x equals the square root of 3x minus 14. Trying to decide if I want to do this last thing with you or if I should let you do it. We'll do it. So again, I'm going to replace y or f of x with y just so my life is easier. No other reason. And then we switch x and y. And then solve for y. So the first thing I'm going to do is subtract 5/3 from both sides. 5/3 is a fraction, and it's just a number that we can subtract, so don't make your life harder by like multiplying or dividing by 5 or 3. It's just a number. And then, so this is the reason that I wanted to, I in the end decided to do this with you. The opposite of taking something to the third power is third rooting something. So I know that we talked about that, but it was a long time ago. The way that looks is we put a little 3 in front of like something that looks like a square root, but it's not a square root because it's a third root. That undoes this to the third power. So our f inverse of x is going to be the third root of x minus 5/3. The opposite of any power is the root. Powers and roots are opposite. Okay, so that's sort of the algebraic part of today's lesson. Now we're going to talk about more theoretical math here. Essentially, every function can be inverted, but sometimes the inverse isn't a function, and I will be more clear about that in a second. First, we just have to talk about what it means to be a function. Calling something a function means that you're saying for every, and I have to write all of these words, hang on, for every unique input there is only one output. This is a lot easier to understand as the vertical line test. And from teaching this before, I know that you've heard of that before. Basically, what this means is that if you plug in one number, you can't get more than one number out. So any function that gives you 2 answers for one input is not a function. So here's 2 things. There's x squared and the square root of x, which we'd already said those are like opposites of each other, right? But let's look for a second at their graphs here. This is a parabola. Clearly it is, hang on, let me find my colors again, sorry. Clearly it's a function, right? If we pass a vertical line across the whole function, let's see if I can be snazzy about this. Maybe not. We don't need that anyway. Okay, so here's what we're doing. We're passing this vertical line across this this function, and we're checking to make sure that it never crosses this vertical line more than once at a time. This function only ever crosses it once at a time, so this is indeed a function. Parabolas are functions. We love parabolas, right? Its inverse right now is most certainly a function. There we go. This is the graph that we actually, in class we did this as a warm-up. We graphed the square root of x, but we talked about this when we talked about transformations of functions. The square root of x graphs like this. Because the only outputs that happen when you plug in the square root of x, plug some stuff into the square root of x, is the positive solution. So remember that when we square root both sides of a function, we always have to put a plus or minus. This is the reason why, because the opposite of squaring something is actually plus or minus the square root. What we're missing in this function is this other half of the graph that would make it look like the inverse of x squared. But if that exists, then this is no longer a function, because this, hang on. this will not pass the vertical line test, right? It's touching twice. So the real inverse for x squared is plus or minus the square root of x, but that is not a function. It is because it doesn't pass the vertical line test. So the inverse of x squared is not necessarily a function. This is the real inverse, which is not a function. So here's what I want you to get out of this. I know that was a lot of stuff. What I want you to get out of this is that if you pass a vertical line test across a graph, then it passes, right? This verifies that it's a function. What you can do, notice that this graph, the one with the completed opposite side, is just this graph flipped sideways. So if you want to skip graphing the inverse, you can pass a horizontal line test across the function to see if the inverse is a function. If it doesn't pass, which this one does not pass, then it's not a function. So this is a horizontal line test. I'll put a little h, horizontal and vertical. The vertical line test tests if the graph is a function. The horizontal line test tests if the inverse is a function. And we'll do some examples of those. First, let's just talk about domain and range here. So the true inverse functions have inverted domain and range. So that just means that if your function spans negative infinity to positive infinity in the x direction, then the inverse will span negative infinity to positive infinity in the y direction. So you just switch, again, x and y. You switch the domain and the range. So the domain of the original function becomes the range of the inverse function, and the range of the original function becomes the domain of the inverse function. Once again, x and y switch. That's on there because I think there are questions on your homework like that. So what we're doing with 1, 2, and 3 down here, it just says decide if the inverse is a function. So what we're doing is we're passing vertical and horizontal line tests over these graphs to see if the original is function and if the inverse is a function. So here's my vertical line. If I pass that vertical line over this graph, notice that it only ever crosses that vertical line. It only ever touches once. So I'm going to put a little check mark here, indicating that the original is a function. Next, I pass a horizontal line test. A horizontal line test over my graph, and notice that it immediately fails. There's immediately 2 crossing points on that horizontal line test, and so that means that the inverse is indeed not a function. I'm abbreviating. Not a function. Again, on this one, if we pass a vertical line test over the whole thing, then it passes just fine, easy enough. So again, the original is a function. Those notifications are for D&D Club. Super fun if you want to join. Anyway, if we instead though pass a horizontal line test over the graph, watch it immediately fail as well. It doesn't pass at all over here. It doesn't cross it at all over here. I've lost all my words. But down here, it immediately crosses it twice, which is failing the horizontal line test. So the inverse is a function, but the original is a function, but not the inverse. Let's try one more. The vertical line test passes. So it is a function. The original is a function. Let me just copy this because I'm lazy. Paste. And then let's also try a horizontal line test. I gave it away because I used green. But the horizontal line test, I'm tired already and it's like 9 a.m. Horizontal line test also passes. It never, like here it's kind of questionable because it looks like it's almost horizontal there, but in fact it doesn't. That's only a single time that it crosses the entire way through. So the original is a function, but so is the inverse. The inverse is also a function in this one. The inverse is also a function. So those are vertical and horizontal line tests. They're very useful in deciding whether or not things are functions. I have a couple more things I have a blank page here, and I have a couple more things that I want to add to these notes. Just some definitions, vocabulary that are useful for your homework. We're going to say this is some function vocab. So, first we have even and odd functions. I'm trying to decide how to lay this out on here. Even, this is why we have books, because I can't make up my mind. Even functions and odd functions. So even functions are mirrored around the y-axis. So it just means that it's symmetrical around the y-axis. This is the official definition. F of negative x is the same thing as f of x. It just means if you plug in the negative version of a number, you'll get the same as the positive version. So something that is an even function is a parabola that's centered on the y-axis. That one is symmetric around the y-axis, so it's an even function. Odd functions are symmetric about the origin. This is a little bit harder to define here. The official definition is that f of negative x is equal to negative f of x. These functions are symmetric, but they are sort of opposite symmetric. So this function, this is a cubic function, is symmetric about the origin. Essentially, it just means if you folded this function like this, well, actually, that's not good either. It's kind of like you flip it this way, and then you flip it upside down. It's kind of like flipped around the y-axis and then the x-axis. Anyway, so this is how you sort of recognize odd functions. There are questions about that on your homework. And then one last one, there is a function called one-to-one functions, like a vocabulary word, one-to-one functions. That just means that both the original and the inverse are both functions. So we just had an example of that when our graph passed the horizontal and the vertical line test. Both the original and the inverse are functions. It passes both vertical and horizontal line tests. Okay, that is all I have for you. Just gonna highlight some things so it's more obvious what we're defining, and okay, and there we go. So that's all I have for you. Let me know if you have questions.